In this example, we're going to look at evaluating definite integrals involving trig functions. You're going to need to turn to this notebook, and within that, if you turn to this page, and we're going to do the example shown here. So we are going to evaluate the integral of 4 sine 3x minus pi with respect to x between the limits of pi and pi over 12. So the first thing that we need to do is to realise we're integrating sine, so that changes it to minus cos. So using the rule, we are going to get the integral becoming minus 4 over 3 cos 3x minus pi, and we are integrating that between the limits of pi and pi over 12. So what we need to do next is just substitute those limits into it. Of course, there's one thing we could do just to make the whole thing a little bit easier, and that is to take that minus 4/3 out, take it out to the front, and we can just completely ignore it all the way through until we get to the end, and then we'll only need to deal with it at that point. So as I said, I'm replacing the letter x with the upper limit, pi, take away pi from that, and then I'm going to subtract from that what I get when I replace the letter x with the lower limit of pi over 12. Minus pi. So we just need to simplify that. The first bit's easy, of course. 3 pi minus pi is just 2 pi. This next bit's a little bit more difficult because we have to work out what 3 pi over 12 take away pi is. So by all means, if you're working on something like that, do a little bit of working at the side. 3 pi over 12, of course, is just 1/4 pi. We're taking away pi from that, so that gives us minus 3/4 pi. So that's what we need to evaluate. The next part is straightforward. We need to evaluate these things. The cos of 2 pi is something that you should be able to do without too much bother. If it helps, draw a sketch of the graph of cos x. But you should know that the graph of cos 2 pi is the same as the cos of 360, which of course is just equal to 1. And from that we're subtracting the cos of minus 3 pi over 4. And that definitely is quite tricky. So if we're trying to evaluate the cos of minus 3 pi over 4, a bow tie diagram is quite useful. You need to think carefully about which quadrant minus 3 pi over 4 is. So basically, since it's a negative, that means we're working round in a clockwise direction, and 3/4 of pi would be round to there, so that's where minus 3 pi over 4 is. half a turn, of course, would be minus pi. We're going just 3/4 the way around that bottom half. So we'll get it there. So we use the bow tie diagram, and the important thing with the bow tie diagram is just to figure out what the size of the angle indicated by these dots, and to figure out the sign of it. So because it's cos, and we've established that it's in the third quadrant, we know that it's going to be negative. So it's going to be negative cos, and the angle that's related to minus 3 pi over 4, just the size of the small dot there, is going to be pi over 4. And that is one of your exact values. At this point, you should be able to recall, or at least to figure out, that the cos of pi over 4 is 1 over root 2. So the answer we get is minus 1 over root 2, which we can now substitute into our integral that we're trying to evaluate. So we're nearly there with this problem. So a little bit of work to do in simplifying this. We could rewrite it as root 2 over root 2. Minus minus, of course, makes a plus. Plus 1 over root 2. And then we can express it as a single fraction. We can make it minus 4 over 3. Times root 2 plus 1 over root 2. And that is basically the answer. We could take it a bit further. We could, for example, try and rationalise the denominator, multiply through by the whole thing through by root 2 over root 2 to get rid of that root 2 in the bottom. However, that's enough at this point, I think, for this example. You should have a go at the examples on exercise 12b on page 289, and in particular questions 3 ACE, questions 4 ACE, and question 5 if you've got time to get a good bit of practice at these type of questions.